So good morning everyone. Today we are going to see about the error correction. So in digital communication, we have already seen about many transmission media, which is transferred from digital signal to analog and analog signal to digital transmissions. Like that way, we have seen many conversions. But in digital signal encoding, what are the error corrections? What is going to done if we are going to briefly see about this in this ppt. So introduction about in error correction. So what is mean by error correction means in digital signals, what are the drawbacks that we have used to transfer the data from one place to another. We can use only guided media. We use guided media or another unguided media. If we use copper wires, optical fibers or wireless media anyhow, they may be affected by some noise or the signals will be not connected, or distortion will be occurred, or unattention. So these are the imperfects which have been happened when the transmission media, the data is when transferred to one from to another. So this impairments can introduce the errors that which is transfer the data by when it's received. So to overcome this challenge, so this error correction technique is used in the signal coding. So this is why it is introduced. So this error correction is just reliable data transmission, which is a paramount, and it is used just to fix the incurrent caused by noise, and at the same time the error corrections or signals encoding retransmissions. Like that way, what are the errors occurs by the transferring the data, it will be make the correction. So understanding what is the types of error means, there are four types of errors which can be occurred. One is signal bit errors, next is source of corruption, and tailored strategies, and burst errors. So the error correction is a process of detecting automatically and correcting the errors. Sometimes it will be automatically corrected the errors by reloading, or affect the signals have been normally we could try that, if we connect the net, or if we don't connect, and otherwise we will be switch off, or we can do anything something else, it will be connected. So sometimes it will be the network will be cost very slow. So these are the scenarios, and the tailored strategies is the nature of the error, which detects the correct strategies to employed, and ensure the robust data recovery. So this source of corrections, which errors terms delivers the factors which includes the electromagnetic interference, fault hardware components, or inherent noise in the communications line. So in burst errors, which involves the multiple consecutives of bits being corrected with data sequence, and then caused by the prolonged disturbance or physical damage, or any physical damage, or storage media. And single bit errors which occurs in uh, when converts 0 becomes ones, and ones becomes 0, which is due to transfer the inferences or noise. Thus and also we here using the uh, two major main approaches. One is forward error correction and automatic repeat request. That is forward error corrections will add enough redundancies to receive can both the correct the errors directly. It can be directly, the errors will be corrected directly. And there's error corrections, and next is we have seen about the automatic request, that is ARQ, which receives the transmissions data and corrupted the data. So here the role of error corrections, so to overcome this, which here enables the inherently noisy channels like Wi-Fi and satellite links, and reduces the need of costly data transmission, and prevents the data corruption in critical situations from deep space probes to financial network. So next we are going to see about the classical error corrections methodologies. One is parity bits, conventional codes, forward error correction, and block codes, which are we have seen about the forward error corrections, which adds the redundancy to receive the, and most very powerful technique is forward error correction, which receives the correct and it will correct the errors by automatically. And parity bits, this is simplest form of error detection, where extra bits is added to ensure to even odd numbers to ones as detecting the single bits. And block codes is a segment block. It is represents as a data segment, so it will represents as the block codes that fix the size of the blocks with the redundant bits. And conventional codes will uses the process of data which continuous streams with the encoding current bits. Next we are going to see about the key error detection techniques. So key error detections, this is which is checksums and parity checks and cyclic refund checks, CRC, and detection and correction. So next we are going to see about the fundamentals of error correction codes. That is fundamentals of error correcting codes is represents by the redundancy introduction, Hamming distance concept, and redundance of trade-off. So this ERC, that is error correcting code, which represents the automatically use the correcting the data errors. So this is the spectrums which we use the uh, errors. So next we are going to see about the future flawless data, that is virtual low, adaptive solution, optimization, and future horizons. Thank you.